Good morning, everybody. Welcome to another wonderful week of geometry. Today, we are going to be discussing biconditional statements. So, it goes back to what we talked about on Friday when we started talking about our conditional statements, and then we had five kind of what happened outside of that. So, we had our original conditional statement, okay, and then from that, we could create our converse, which was Q to P, our inverse, which is squiggly P, squiggly Q, and our contrapositive, which was squiggly Q, squiggly P. Okay, so we kind of talked about those four, and then at the very end of class, we discussed this thing called a biconditional statement. Now, you guys didn't have anything over the weekend to do with it. We saved it for Monday because biconditional statements have a lot going on, but only because it looks like it could be annoying, but it's not. So a biconditional statement can be formed if, only if, your conditional statement, your conditional statement, sorry guys, new stylus, handwriting's a little terrible, and your converse are both true. Then we can combine them into one single conditional statement. So the first thing we've got to do is we've got to verify that our conditional statement is true and that when we rewrite it as the converse, that is also true. So our first example, they're telling us this is true, so I don't got to figure out whether or not it is. And it states simply, if a shape is a triangle, then it has exactly three sides. We're all brilliant mathematicians, so we know triangles have three sides. So if I flipped it around, remember, if I'm writing the converse, my hypothesis becomes my new conclusion, and my conclusion gets written as my new hypothesis. Okay? So if a shape's triangle has exactly three sides, that is true. And then our converse of that is if a shape has exactly three sides, then it is a triangle. Of course, no matter what happens, as long as that shape's got three sides, we're going to call that rascal a triangle. So what we want to do is we're going to take this, the if and the then are going to be taken out, and we're going to write this as a biconditional statement. So if and then are replaced with this little phrase, if and only if. Okay, so we're going back to our original. The shape is a triangle. Shape is a triangle. And then here it comes. If and only if. And then we get it has exactly three sides. So notice that the if and the then are gone. Okay, and it got replaced by that statement in blue. If and only if. Okay. Our notation for that is this guy right here. So we get this P, and then guys, this arrow kind of has to be connected. Word's a little funky. So we're going P, arrow to arrow, Q. And that means what can happen is I can write P first, I can write Q first. It doesn't matter. They're interchangeable because it's going to create this biconditional statement. So a couple of examples. We're going to write each conditional or each biconditional as a conditional and its converse, and then determine whether the biconditional is true or false. So I know you guys are loving my handwriting, but to help me out here, I want to write it. I want to text it in. Hopefully you guys don't see all of it coming in, but I'm going to hit text, and it shouldn't be. Oh yeah, that's going to pop up nice in the way. Okay. An angle is a right angle if and only if it measures 90 degrees. So if we can help ourselves identify. Let's get that out of here for now. So I've got two pieces. I've got our angle is a right angle, and I have it measures 90 degrees. So what we're going to do is we're going to take and we're going to separate our biconditional statement, and we're going to create. I wish this was a little smaller. Sorry guys, it's kind of in the way. The wonders of technology. So if an angle is a right angle, then its measure is, not an O, 90, and if you hold the O, you get degrees. Okay, so we took that original biconditional and we wrote that. So now what we're going to do is we're going to write it with the yellow first this time, because that is how we create our converse. If an angle measures 90 degrees, comma, then it is a right angle. So what we want to do now is we want to check our two statements and make sure they're true, because if one of them is false, then we do not have a true biconditional statement. So it measures a right angle. So if it is a right angle, if an angle is a right angle, then the measure is 90. Yep, that's a true statement, so that one's okay. And then the next piece, if an angle measures 90 degrees, then it is a right angle. So we've got a true biconditional statement. Okay, let's look at our next one. Again, we want to take this biconditional statement and we're going to break it down into its pieces. Again, I want the text because my handwriting has been atrocious on this thing. So it's kind of a smaller sentence. And there's no exact right answer for this, guys. As long as we hit the big, like, major points, it's going to be there. So x is greater than -2 if and only if x is positive. Right now, your math senses should be tingling, and that should sound like not a good thing. So let's see. If x, I know is greater than -2, then x is positive. Yeah, my math senses are tingling on that one. Let's see on the converse. If x is positive, then x is greater than -2. Now that one looks pretty good. So our converse, if x is positive, then x is greater than -2. Now that's a true statement. That is going to be absolutely correct. So this is a true statement. That guy's okay. Because no matter what x is, it's going to be positive and it's always going to be greater than -2. But our first one, if x is greater than -2, then it's positive, isn't quite correct. Okay, so what we've got here is this is false. And all you've got to do to prove it false is provide a singular counterexample. And for me, my counterexample is going to be, what if x was -1? X equals -1, okay? That is greater than -2, but not positive. So that proves that this is not a true biconditional statement, so we can't roll with it. All right, so now they're going to give us our conditional statement, and we're going to create the biconditional. Sorry that I didn't write that in there, guys. The biconditional, and then the converse. So for me, I'm gonna write we are going to create the converse first. Okay, we're gonna write that one first. Because if my converse isn't true, there's no use creating a biconditional statement. So let's see what happens. So our conditional statement, if the date is July 4th, so there's my hypothesis, the date is July 4th, then it is Independence Day. So my hypothesis, the date is July 4th. My conclusion, it is Independence Day. So let's create our converse first, because again, that's got to be a true statement, because that's the only way our biconditional works. So I want to take that, it is Independence Day. Sorry guys, I didn't do a different color. That's a bad Mr. Coach. There it is. Okay. Created this nice yellow green there. Okay, so we're going to take that yellow green color and we're going to write it first in our converse. So if it is Independence Day, underrated movie. The second one was not very good. First one was solid. Big shout out to Mr. Will Smith. And if it is Independence Day, then the date is July 4th. So, is that a true statement? Absolutely. We love to shoot fireworks and hang out with our friends and family on Independence Day, which is also July 4th. So, because of that, we can create our biconditional statement. How about I do it in, what do you guys think? Red, you want to do it? Oh, that's not the right thing. I don't know what's happening here. I used to be able to do colors. Oh well. Up style. Sneaky, sneaky. So I'll write it in red. I know there's a lot going on, guys. This is what you don't see, the behind the scenes incident. Because when I airplay, y'all don't see all this. Alright, so zoom out a little bit. Didn't realize I was completely on the board. Okay, so our biconditional statement is the date is July 4th. Didn't mean to all caps that guy. If and only if. There's our biconditional segment. It is Independence Day. So again, there's that key piece we need, guys, that if and only if. And if you remember from our notes on Friday, we can write that, the if and only if, as IFF. I believe on your homework you'll see that a couple of times. That IFF piece. Okay. Our last example for the day. If two angles are congruent, let's get my different colors rocking and rolling, then their measures are equal. Okay. Two angles are congruent. Thank you for not being perfectly straight, is my hypothesis. Remember, we do not include the if or the then when we identify our hypothesis and conclusion. And then their measures are equal are it is my conclusion. So we want to write our converse first. So we're going to text. Let's change it back to black. It is back in black. Sorry. So if our green's going to come first. So if an angle, if two angles measures are equal, then they are congruent. All right, is that true? Absolutely. If two angles are equal, congruent. So remember, angles are equal, numbers are equal, angles are congruent. So if they've got the same angle measure, now that's the same angle, and we enjoy that they're congruent with one another. So from our biconditional, we can kind of create, see, we can go back to red. It's not as quick, but it's okay. Go back to red. My text box is getting all wonky here on me. Okay, two angles are congruent if and only if their measures are equal. Spread that out. Right, and again, there's our key word, the if and only if, which means it must be true. Okay. Thank you guys for watching. Your homework is on my math lab. Please work quietly and y'all have a wonderful day.